All right, today, 1, 4, 18, right? And our Common Core standard today really is adding or subtracting rational expressions. And again, you may use your notes on the next or the last test, okay? You can use your notes, so make sure you take good notes, all right? You can't use somebody else's notes. So, example 1, it's just basic, simple stuff that we've done before. Obviously, 1/5 plus 3/5 has got to be a 4/5, right? It already has a common denominator, and then we're just going to say how many fifths we have. 1 plus 3 makes a total of 4/5, right? There's no tenths. There's no tenths up there. Take an apple or take a pie and break them into fifths, right? Fifths. You've got 1/5 and 3/5 pie, right? You've got 4 pieces of pie and they're fifths, right? No tenths, right? Okay, example 2. Now the only problem with example 2 is that we're going to need a common denominator because you can't add 7/12 and 1/4 without a common denominator, right? Common denominator, okay? So if I take my 7/12 minus the 1/4, to make it a common denominator, you're going to make it into a 12. So if I multiply 4 times 3, I'll get 12, but you have to do top and bottom by the same number. You have to multiply by 3 over 3 because of that property 1. When I multiply something by 1, it does not change its value. Right, Leora? That's the y piece, right? That's why we do top and bottom the same number, right? Because you're not going to change the value because you multiply by 1. So then you get, 7/12 minus 3/12, which should equal 4/12. Now, is that a good enough answer? Not really, because 4/12 can be reduced, right? Into 1/3. Okay, this is 5th grade math, right? No problem. We got this. This is easy, okay? Example 3 is a little different because we're probably going to have to multiply both, right? So if I have my 5/12 plus my 3/8, I need to make a common denominator, okay? So one way that always works, which isn't always the best method, it always works, is you could multiply this by 8 and this by 12. It will make the same number, 96, okay? Multiply this by 8 and this by 12. No, 108, sorry. It will make the same number, but that won't help you at all, okay? It will, you can do it, but why not use something a little bit smaller? So what number would they both go into? How about 24? Okay, were they both going to 24? Sure, so I can make them into 24 by multiplying this one by 2 over 2 and multiply this one by 3 over 3. And then I get a common denominator that's already kind of reduced, all right? So the smaller number you can pick, the easier it is to reduce. Does that make sense? The smaller common denominator you can get, the easier it is to reduce. So at this point, I'll have a 10 over 24 plus a 9 over 24. I have a common denominator, so I can add them. So I'm just going to get a 19 over 24 is my answer, okay? So I'm sure we got thumbs up, right? I'm sure we do, okay? Now, in example 4, it's the same exact idea. It's the same concept except we got x's. That's okay. So the first thing is on example 4, does it have a common denominator? Heck yeah, it does. It has a common denominator. They both are an x plus 3. So if it has a common denominator, what I'm going to do is just write it down. X plus 3. Just put it down. Okay, first thing, it's got a common denominator, just write it down. I'm not going to write it down twice. I'm just going to write it down once because that's a common denominator. Now we're going to add the numerators, right? So I'm going to add 3x and 2x gives me a 5x. And a negative 4 and a positive 5 makes a positive 1. If you can reduce, we will do so. Reducing takes factoring and canceling, okay? If we can reduce, we will. Reducing takes factoring and canceling. We cannot reduce this one, okay? All right, let's check out number 5. We might be able to reduce some of these. Okay, example 5, again. Do you have a common denominator? Yeah, we got a common denominator, right? So our common denominator is simply going to be our x squared minus 4x, right? Just write it down. Now we got to be careful because we're subtracting. The biggest thing we have to be careful when we subtract is the double negative, okay? So hopefully we won't mess that up. But if I'm going to go 2x minus 4x gives me a negative 2x. Negative 2x, come on. Okay, 2x subtract 4x. So negative 4x. Now you're going to be careful of this double negative here. See my double negative? So I'm going to go 2x minus a negative 5, right? So I'm really going to add. I'm going to go 2x plus 5. Do you see the plus 5? Because you get your double negative, right? So it's really going to be 2x. I'm sorry. It's really going to be negative 1 plus 5, which makes a 4. Okay, positive 4. Okay, so what I did, I'll put it on the side here. I'm really going, put this over here. I'm really taking negative 1 minus a negative 5. Right? I'm really going to negative 1 subtract negative 5, which is really the same thing as negative 1 plus 5, right? So you're okay with my 4, right? There's my 4. All right, now, I can factor. I don't know if it's going to do me any good. Maybe. If I can factor, maybe I can reduce it, okay? So let's factor and see what happens. So if I factor out a negative 2 out of this one, let's see, negative 2, I'd have an x minus 2. And if I factor out an x, I'd have a x minus 4, okay? It didn't help. It didn't help. Sometimes it can. I did factoring, nothing's going to cancel. So I'll go back to the answer I had above, okay, which looks a little bit nicer, okay? Sometimes you can factor and things will cancel and then it reduces, okay? That one didn't. We'll come up with one eventually that will, okay? Okay, how am I doing? Thumbs up, okay? Am I going too fast? Thumbs up. Okay, here comes the fun ones. Common denominator, right? Here comes the fun one. So, if we go back to our reading, it said factor each denominator, but not the top. Okay, so factor the bottom, not the top. So let's go x minus 1 over x plus 1, x plus 2, right? Right, how am I doing? So just going to factor the denominators. Well, this will factor into x plus 1, x plus 2. Multiples of 2 that add to 3. This obviously can't be factored, okay? Now, same thing on the common denominator. We want them to be the same. They both have an x plus 1. They both have an x plus 1, but this one has an x plus 2. So to make them the same, let's give this the x plus 2 so they'll have the same thing. So I'm going to go ahead and give it an x plus 2, but you have to do it on the top and bottom, like we've always done, right? It's that property of 1. Okay? Now let's see what we got, okay? So they have a common denominator. I'm going to write that down. And that's going to be my x plus 1, x plus 2, right? So on the top, I can't add them yet because this is kind of like needs to be distributed. So on the top, I'm going to have an x minus 1 plus an x squared plus a 2x, okay? You see where I got the x squared plus 2x? Because you can't really add them in this form. You can't really add them yet. So I need to distribute. Okay, now I look at it and say, okay, what can be added? Well, I can add these two here, right? Make it a 3x. So I'm going to add the numerators. Add this. I'm going to add the numerators right here. And I'm going to get an x squared, right? I get an x squared plus 3x minus 1 over my x plus 1, x plus 2, okay? Now, if I could factor and cancel, I would. Because that would reduce it if I could, but I can't. It won't factor. Multiples of 1 aren't going to make a 3, okay? So you're done. I mean, if I could cancel some way, factor, cancel, I would, but I can't, so I'm done. That's it, okay? How am I doing? Thumbs up. Okay, I see one thumb up. Okay, 2, 3, sideways. How many sideways? Okay, good. I see lots of thumbs up. That's good. Okay, example 7. Okay, let's see. Okay, common denominator, okay? Factor each denominator, right? Factor the bottoms, not the tops, okay? So I'm going to change this. Let's see, I got an x over an x plus 3 minus an 18 over, let's see, this is going to be x plus 3, x minus 3, right? You guys agree with that? So, what is, they both have an x plus 3, right? But this one has an x minus 3 and this one doesn't. They both have an x plus 3. This one has an x minus 3. This one doesn't. So let's give this first fraction that x minus 3. Okay, so got to give it an x minus 3, but we've got to do it both top and bottom. X minus 3, okay? Right? Property of 1. So now we have a common denominator. Common denominator is my x plus 3, x minus 3. And my numerator then becomes an x squared minus 3x minus 18. Okay, I think I can do something with this. I think for a change I can go a step further. I think I can probably reduce. Does the numerator factor? Right? It does, right? You guys agree the numerator will factor? How about a negative 6, positive 3? With me, negative 6, positive 3. So let's factor, okay? Let's factor the numerator. And let's rewrite this then as an x minus 6, x plus 3, right, over an x plus 3, x minus 3, okay? Now we've got enough that we can actually reduce it. So it will reduce by canceling the x plus 3's over the x plus 3's, right? And what we finally wind up with is an answer of x minus 6 over x minus 3. And that is the answer. Don't cancel the x's, right? Don't cancel the x's and don't make this 2. We talked about that yesterday. Do not do that because you need the entire top divided by the entire bottom. Okay, so don't cancel. Don't cancel the x's. Don't make that negative 2. Okay? All right? Turn the page. Am I doing okay? Okay. Okay, now, example 8. So, example 8, again, when I look at example 8, it sure looks like I could factor the top, but I don't want to do that. Don't factor the top because then you can't add them. I'll say it again. Don't factor the top because then you can't add or subtract. Leave it alone. But I can factor the denominator. So I'm going to go, okay, 2x squared minus 16 over an x plus 2, x minus 2. Okay, so just factored. So all I've done is factored my x squared minus 4 into that, okay? Minus my x plus 4 over my x plus 2. Okay, now, same thing. If I look at both fractions, they both have an x plus 2. Okay, so that's the same. But the second fraction doesn't have an x minus 2. So let's give it an x minus 2. So, all right, to get a common denominator, let's give it an x minus 2. But of course, property of 1, you got to do top and bottom to make it an x minus 2 also, okay? All right, now I'm going to have to do a little bit of work. Does not scare me. I can do that, okay? I got to do a little bit of work. So first of all, my common denominator is my x plus 2, x minus 2, okay? That's my common denominator. Just write it down. Okay, now I'm going to go slowly with this, okay? So that's what they have in common. There's my common denominator. Okay, you ready? So on the top is going to be a 2x squared minus 16. And then we're going to do some distributive property here, okay? We're going to do our FOIL. We're going to get a negative x squared, positive 2x, positive 4x, minus 8. Okay? Positive 8. Hold on real quick. Hold on, I might have to do this up above. I'm trying to do it a shortcut way. But you will get the positive 8, yeah, because we'll get a negative positive 8 here. Actually, you know what? I'm going to do this FOIL up on top, and then we'll bring the negative through first. I'm not going to make that mistake. Okay, hold on. Let me do this real quick. We'll do an x plus 4, x minus 2 on top, which is going to give me x squared plus 2x minus 8. And then I bring the negative through, negative x squared minus there, plus there. Thank you. Is that Connor? Is that Simon? Yeah. Okay, so let's see what we got. Got a mess, don't we? So on the top, we're going to have then a 1x squared because of those two, right? Let's see. You got a 2x and a minus 4x makes a negative 2x, right? We got a negative 16 positive 8, which makes a negative 8 over an x plus 2, x minus 2, okay? How am I doing? Can I do more? Yeah, I can factor that one. I can factor that one into an x minus 4, x plus 2 over my x plus 2, x minus 2, right? Reduce, cancel, cancel, and I'm left with x minus 4 over x minus 2, okay? That was a good problem. I like that one. That was good and hard. All right, example 9. I'm running out of room, but I think I can squeeze example 9 in. Am I going too fast? Am I okay? Emma, am I going too fast? Okay, am I okay? All right, last one. Okay, I got a fraction within a fraction. So how am I going to do this? Well, first of all, let's just deal with this top part. This is a complex fraction. Let's just deal with this first, okay? So I'm going to put all of this work right in this space here. Okay, so I got a 2 over x plus an x over 2, okay? I'm just going to deal with that over there. Just going to take the top part of the numerator of this complex fraction. I'm going to deal with that first, okay? Now, I can't add those yet, can I? Because they don't have a common denominator. So I'm going to multiply this by 2 over 2, and I'll multiply this one by x over x, okay? Because I need to add them, so they need a common denominator. So their common denominator is 2x, and on top I'd have a 4 plus x squared, okay? All right, all I've done is simplify the top part of this fraction, okay? Now all of this is divided by, if I bring this back in, right? All this is divided by x plus 1 over x, okay? Now we have a fraction divided by a fraction, right? Okay, am I going too fast? Now I have a fraction divided by a fraction, okay? So what am I going to do with that? Well, I know how to divide fractions. I invert and multiply, right? Flip the second one. So I'll rewrite this as a 4 plus x squared over 2x times, right, x over x plus 1. Can anything cancel? There's something. There's something. Can anything cancel? How about the x's? You guys okay with that? Right? And nothing else will cancel, so my answer is going to be a 4 plus x squared over a 2 times x plus 1. All right, of all the things you're going to do, this is probably one of the hardest because it's fractions, it's add and subtract, it's common denominators, okay? Aren't you glad I saved it till the end? Yeah. Okay, please try the homework, you guys. There is a real value in doing the homework. Page 588, 3 to 13 odd, 30, 62 to 64. The value in doing the homework is the practice, right?